In this video, we're going to look at problem number 2 in your homework packet for the problems on pages 5 and 6. So the problem they give is talking about taking carbon monoxide here, which is CO, combining it with oxygen and forming CO2. Now, remember we're talking in terms of moles, so we can have 1 mole of CO combined with a half a mole of O2 forming 1 mole of CO2. Remember, we can have a half a mole of substance. Now, this looks like it's going to release energy, 67.6 kcals, and ultimately it's going to have a negative delta H, meaning energy was released in the process. So it is going to be an exothermic reaction. So really we're combusting a gas and making another gas in this case. So to solve this problem, there are a couple steps, and you have this, I think, on page 9 of your homework packet. One thing is determining the equations that will add up to give the final equation. And the big hint with that is focusing on compounds, not elements. So when I go here, I'm going to look at carbon monoxide and I'm going to look at CO2. I'm going to hope oxygen cancels out on its own. So I'm going to go to my toolbox and look for carbon monoxide. And if I look there, I see it in equation number 1. It's the only one that has carbon monoxide. Now notice carbon monoxide's on the right side of the equation, but in order to get equations adding up, I want it to be on the left. So what I'm going to do is follow this rule number 2, where it says reverse equation, including the energy term if necessary. The compound you're isolating should be on the same side as it is in the final equation. So back to this. I'm looking at equation number 1, and I'm going to put the CO and the 26.4 on the left, and the C and the 1/2 O2 on the right. And the rationale is, if it releases 26.4 kcals in forming CO, it's going to absorb 26.4 kcals when combined with CO. So again, if you reverse a reaction, the energy is just going to be on the opposite side. So we take this equation, we put it there, we flipped it, or I said it was reversed, tool number 1, and notice it's endothermic, that process, so I say 20 plus 26.4. Let's say I had 2 COs right here, I'd have to double it, or 3 COs, I'd have to triple it, but I have 1 CO here, 1 CO here, so I don't have to worry about multiplying that. I'm going to skip over the half O2. I think that's going to cancel out on its own, or at least I'm hoping it is, and I'm going to look for CO2. Again, I'm going to look in my toolbox, and in my toolbox, I see that is tool number 2. It's the only one in there that has CO2. It's on the right side of the equation and the correct side of the equation. So we are going to keep it because it matches. So I'm just going to copy this down exactly as I see it. C plus O2 forms CO2 plus 94.0 kcals. Okay, and again, if this were more than 1 CO2, I'd multiply it by whatever number I needed to match up here, but in this case, the 1 matches the 1, so I don't have to do that. Now I'm going to look for like terms. So I'm adding like these 2 simultaneous equations like you might do in algebra, adding up to equal the overall equation, and see if these steps match up. So I look and I have a carbon here and a carbon here, they cancel out. And I have a half oxygen here and a whole oxygen here. Well, I just broke up the half of the whole oxygen into 2 halves. And by doing that, I could say, oh, I got a half oxygen here, it's going to cancel out with half oxygen here, leaving me with a half left over. So the bottom line is I really just have CO plus O2, or half of O2, which is left over here, forms CO2, which matches up to this equation. So if you get a match between the elements and compounds, then you know, even if it's not the exact path, it's a viable path that will give you the same amount of energy. So looking at that, equation 1, I absorb 26.4, in equation 2, I released 94.0. So I have a net loss in energy of 67.6, reflected by delta H being negative 67.6 if we're talking about my energy loss. Just like if I went to Treasure Island and absorbed $26.40, woohoo! Then I go back and I release $94, I have a net loss. What's the net loss? It's the difference between the two amounts. In this case, it would be $67.60. Okay, or if I said, what was your net effect of going? It would be negative 67.6 because I lost money when I was there. Okay, so just a little picture type thing, showing this like we did the other day. You won't have to do this when you're writing things out, but it might help you see it. I have carbon monoxide. It takes energy to rip that up, so that's the energy absorbed. But then it releases energy. It releases 94 kcals going down to this spot right here and forming CO2. And so my overall net effect is losing negative 67.6 kcals of energy. If you think about it, carbon monoxide's not very stable. Carbon dioxide's a lot more stable. So it's going to release energy going from carbon monoxide to carbon dioxide. And that's why that is exothermic. Thank you.